Okay, in this concept, we're going to talk about inequalities. So, an inequality is a mathematical statement with the following symbols. So, either the greater than symbol, the less than symbol, greater than or equal, or less than or equal. As opposed to an equation, which just have an equal symbol, right? Something equals something, right? 2x, equals 5. This is an equation, right? You could solve for x, and then you would get a single value for x. In this case, for example, x is, 5 halves, right? So x is equal to a single value. An inequality, however, produces a result that in general is a range of values, okay? A range of values as opposed to a single value. And we'll get to that momentarily. Let's look at some quick steps in order to solve an inequality. Okay, so first you would isolate the variable to one side of the inequality, and then the rest of the terms, the non-variables, to the other side of the inequality. Then you would change the sign of the term while moving it from one side to the other. So if you're moving terms, you would change the sign similar to how you would do when solving an equation. Okay, when isolating the variable to one side, in an equation and trying to solve for it, you would do the same thing in an inequality. Change the sign of each term when moving it across across whatever the symbol is. Greater than, less than, greater than or equal, less than or equal. Another thing to keep in mind for inequalities is that if you multiply or divide, okay, both sides by a negative number, then you actually have to reverse the inequality symbol. Okay, so let's say you have, minus 2x, right, is less than, whatever, 3, right? If you want to bring the minus 2 to the other side, right, because you want to remember, you want to isolate the x, you would actually flip this, right? So you could divide both sides by minus 2, right? But you would flip the inequality side. So it would be x greater than 3 over negative 2, right? This is negative also, right? So, and again, we'll look at some more examples of this very soon. And then one thing that's important to do in the end is to graph the solution on the number line when asked, but it's usually very useful to help you visualize the result of the inequality. Let's look at some examples. So solve the following inequalities. Example 1, 1 half x plus 2 is greater than 2. So again, the goal is to isolate the variable, which in this case is x, right? Isolate it to one side. So what we did was we can say, 1 half x plus 2, we can say minus 2 on this side and minus 2 on this side, right? In which case we get, plus 2 minus 2 is 0. 2 minus 2 is also 0, right? So 2 minus 2, that's 0, right? So 1 half x is greater than 0. You want to get rid of this half, so you can multiply by 2, right? So in which case the 2's cancel, you get 1. So you get, and then obviously 0 times 2 is 0, right? So you end up with x greater than 0, right? So the solution to this inequality is any value of x that's greater than 0, not greater than or equal to 0. So 0 itself is not included is not a solution, but anything greater than 0 is a solution. Let's plug in 1, for example, right? For x. So 1 half times 1, right, is 1 half plus 2 is 2 halves, which is greater than 2, right? Let's try 2 for x, for example. 2, so 1 half times 2 is 1, right? 1 here, plus 2 is 3, which is greater than 2. So anything greater than 0 works. Let's put in 0 for x. So 1/2 times 0 is 0, plus 2 is 2, which is not greater than 2. 2 is equal to 2. So 0 does not work. Okay, so 0 is not part of the solution. So the solution is anything greater than 0. And to graph it, you get something that looks like this, right? So on the number line, you would essentially draw an arrow, an additional arrow, on top of the arrow of the number line to show that, to show the range of values that the solution covers. And in this case, since you're not including 0, you would actually use an open circle, right, at the 0, and then a solid line for all the other values. Okay? If you were including 0, you would use a shaded circle or a closed circle. Okay? Let's look at the next example. 15 plus 2x is greater than or equal 2 times 4 plus x. Here we could obviously use the distributive property, right? So we get 2 times 4 and then 2 times x, right? So 8 plus 2x, and then we have 15 plus 2x. What we could do is, again, to isolate the x's on the one side and then everything else on the other side. So we can keep this 2x here and we bring this one to this side, right? So minus 2x, right? And minus 2x. And then minus 15 and then minus 15, right? So what do we get? So we get 2x minus 2x on the left-hand side, and then we get 8 minus 15 on the right-hand side, right? So 2x minus 2x, right, on the left-hand side, and then 8 minus 15 on the right-hand side. So that essentially gives us 2x minus 2x is 0, right? Something minus itself is 0. Is greater than or equal 8 minus 15 is negative 7. So you get 0 greater than or equal negative 7. Well, that's kind of strange, isn't it? Where is the x? Where is the x that's greater than or less than something? Well, when you get something that looks like this, if it is true, then the result is all the numbers in infinitely many solutions. So anything, in other words, any number, any value will make this inequality work. Okay. Of course, it seems like a trivial solution, but it is a true solution. Okay, it is a logical solution. Okay, it's a correct solution. As long as in the end you get something that is true. Okay. If this were not true, right, then the result would be different. Let's look at the next example. Minus 8x plus 4 greater than or equal 28. Again, isolate the x on one side, so in this case we want to bring the plus 4 to the other side, so we would do minus 4 and minus 4, right? So these cancel out and you get 28 minus 4, which is 24, and then negative 8x we still have. Now we want to bring the negative 8 to the other side, so we're going to divide both sides by negative 8, right? Negative 8 and negative 8. But, so these two are going to cancel, but since I'm dividing by a negative number, then I have to flip the inequality sign, right? Since dividing by a negative number reverses the inequality symbol, so now we reverse it to the opposite symbol. So now we don't have x greater than or equal minus 3. We have x less than or equal minus 3. Okay, I'm sorry. Yes, we have x less than or equal minus 3. Right? So we flipped the inequality sign. because we divided by -8, okay, which is a negative number. So this is the final result. X less than or equal -3. Okay? And we can actually graph this on the number line, right? So if we had a number line and we had 0, right, and this is 1, 2, etc. So -1, -2, -3, etc. Now, so in this case, the result would be, we would -3, right, because it's less than or equal to -3. So we would have a solid circle, right? And we would have, more number line, right? Oops. Yeah, I just wanted to make this longer, so now we have this, right? And this just keeps extending, right? So any number that is less than or equal to -3. Okay. Here we have some exercises. Please pause the video, work on these, and come back for the solution. Okay, let's look at this first exercise. So -3x plus 2 is greater than or equal to 15. So again, first step is to isolate x on one side. So here we would want to do -2 and -2, right? So -3x greater than or equal, so these two will cancel out, get 0. -3x greater than or equal 15 minus 2, which is 13. Remember, we're not flipping the inequality sign because we're not dividing by -2, we're subtracting -2. Okay, so addition, subtraction, you do not flip the inequality sign. So -3x is greater than or equal 13. Now I want to get rid of the -3, so I'm going to divide by -3 and divide by -3. Okay, so in which case then I have to flip the inequality sign. So I'm going to have x less than or equal, because I flipped it, right? I flipped it, I went from this to this. So x is less than or equal 13 over -3, which you can just say, -13 over 3. Okay, this is your result. Okay, and then we can actually graph this, and we would get, so let's draw the number line, right? Let's say this is 0. So 1, 2, 3, 4, 5, 6, etc. -1, right? -2, -3, -4, -5, -6, etc., etc. And then obviously, we have the positive side, but we won't really need it. But, let's just draw a couple of the numbers. So -13 over 3 is essentially, so the closest number is -12 over 3, which is -4, right? But then you would have a remainder of, 1/3, right? So it's essentially -4 and 1/3, right? So it's a little, it's after -4. So -4 and then, 3 divisions, right? 3/3. So we start here and we include, right? We include the -4 and 1/3, right? Because we have here less than or equal symbol. So we do include the -4 and 1/3, right? And we go to whatever values are smaller, we just keeps going. Any value that's smaller than -4 and 1/3. Okay? Let's look at the next exercise. So minus 1/2 x plus 1 is less than negative 4. First, let's bring the 1 to the other side by subtracting 1 from both sides, right? So plus 1 minus 1 is 0. Minus 4 minus 1 is minus 5, right? So minus 1/2 x, and then minus 5 is less than minus 5. I want to get rid of this from this side, so I'm going to multiply by minus 2, right? Because the minus times the minus cancels out, or gives me plus, I should say. And then the 2, and then 2 down here cancel out, and they give me 1, right? But then here, though, so I multiply by minus 2 here, then I have to multiply this by minus 2, right? And I have to flip the inequality sign, okay? I have to flip it this way. So minus 5 times minus 2, the negative signs turn into a positive, and then 5 times 2 is 10, and then I have the x because I got rid of the minus 1/2. So this is my answer. X is greater than 10. So again, I could draw a number line, and then let's say I have the 0 here, right? 0, 5, 10. And again, I'm just trying to save space. I mean, you don't really have to draw every single number or every single division. It is understood that, the numbers exist between these divisions, right? So minus 5, minus 10, etc. So x is greater than 10. So I'm going to go to 10 and draw an open circle because I'm not including 10. Okay. So 10, but then I'm including everything greater than 10. Okay. And this is the graph of this inequality. Okay, this is it for this concept. See you in the next video.